Hello everyone. This will be our next homework take-up video. So I asked a few questions here, 2C, 4, 11, and also a very nice question I got. Basically, how are you and your family? How are things going? Which was a very nice to have that asked. Everything's going fine on my end. For example, today my youngest daughter completely destroyed me twice playing Monopoly Gamer here. So that's kind of how my day was. But yeah, things have been good. So I don't know if you have any funny or interesting stories you'd like to share sometime. Feel free to pass that along and help keep a little bit of community spirit going here in these weird times that we have. Okay, so let's get into the questions now. So 471, number 2C. So we're going to find the intersection of these two lines. Okay, we did a similar example in the notes from yesterday. This is my second take on this video because the algebra got a bit messy here, at least when I tried it the first time. So, to always take your time and slow down when you're trying to do these things. So we're going to write this in our parametric form. So my first one is x equals -12 plus 8s. Okay, and y is equal to -7 minus 5s. That's this one. Okay, my other one, my parameters are x equals 2 plus 3t, and y equals -1 minus 2t. Okay, now we set the matching parameters equal to each other. So for my first pair, we've got -12 plus 8s equals 2 plus 3t. And for my other one, -7 minus 5s is equal to -1 minus 2t. Okay. Now I could do these for substitution, but looking at some of the numbers here, that's not going to make sense for some very nice numbers to work with, when I get some messy fractions if I do that. So I think I'm going to choose to do these with elimination instead. So I'm going to rearrange my equations first. So if I bring the variables to one side, my first equation would be 8s minus 3t. On the other side, when I bring the -12 over, I would get positive 14. Okay, for my other equation, I'll bring the t over, so I have -5s plus 2t. And then when I bring the -7 over, that's going to turn into positive 6. Okay, so for elimination, I need either my coefficients of s or my coefficients of t to match. Okay, I can get much smaller numbers if I do t. Right? I can multiply this equation by 2 and my second equation by 3, and I have 6's in both positions. Okay, so when I do that, my first equation becomes 16s minus 6t is equal to 28. Okay, and my second equation becomes -15s plus 6t is equal to 18. So now to eliminate, I've got positive and -6 there, so I just need to add my two equations together. So 16 plus -15 gives me just s, which is very nice. Okay, my t's cancel, and 28 plus 18 is 46. So my s value is 46. Okay, so now I go back and solve for t. Okay, I won't go through that in too much detail. Let's say if I took that first equation, right, I got one of those equations, let's say, I have -5 times s, which is 46, plus 2t is equal to 6. And if I work that around, I get t is equal to 118. Although realistically, once I have one of these parameters in this case, I can just go back and plug it in and see what happens. Okay, and that is my last step. I'm going to take one of these two parameters, S or T, and go back and plug it in to figure out X and Y. So let's say I did S. So using those equations, I would have X is equal to my first equation, which was negative 12 plus 8S. So negative 12 plus 8 times 46. Okay, and when I run that through, I get 356. Okay, and for Y, negative 7 minus 5S. So 5 times 46. And when we run that through, we get negative 237. Okay, so therefore, the point of intersection is 356 and negative 237. Okay, now number 4. Number 4 says determine if the parallel lines in each pair are distinct or coincident. And I just realized I spelled distinct wrong. Okay. So first, I guess this is some terminology I didn't really go over in the video lesson from yesterday. But first, the question says they're parallel, right? And we know that because this direction vector, well, they're scalar multiples times 1, so they're exactly the same. But the key thing is they're scalar multiples, so I know they're parallel. So distinct, start with that. Okay, distinct is referring to the case where, well, they're parallel and they are run beside each other. Okay, so they're separate lines. Okay, coincident, okay, is the case where we were trying to trick you and it was actually the same line twice. Okay, so that's really the question here. I know the parallel, so are these two different lines or are these two ways of writing the same line? Okay, right, we know they go in the same direction. The question is, right, what's with these points? Are those both points on the same line or are they on different lines? Okay, so a couple ways we can check. Okay, one way would be to just check the intersection and see what I get, right? If they're like this, I would get to the case where I have 0 equals 0 when I'm trying to solve the equations. Okay, another way I could do it is just check, right? Is this point on this line or vice versa? Okay, so let's do that method. I think it's a tiny bit faster to do it that way. Okay. So let's see. The parametric form of my first line is 5 plus 2s, and then 1 plus s, and 3 plus 7s. Okay, so if this point is on that line, then that means 2 is equal to 5 plus 2s, 3 is equal to 1 plus s, and 9 is equal to 3 plus 7s, right? That should work. So I start solving each thing for s. Okay, this one is nice and easy. If I bring the 1 over, that suggests that s should be equal to 2. But if I jump to this equation, I bring the 5 over, so I'd have a negative 3, and then divide that by 2. So I get negative 3 over 2 is equal to s. And the last one's even worse. I would get 6 over 7 is equal to s. Okay, so these do not agree. So I must have parallel lines. They do not meet because the point from one is not on the other one. So therefore, these lines are distinct. Okay. If they had been coincident, then I would have got the same value for s in all three spots. Okay, and our last one is question 11. Okay, in free space, there are four possibilities for the intersection of two lines. If one line is the y-axis, give a possible equation for the second line in each of the four cases. Okay, so let's start by developing the equation for the y-axis. Okay. So here's my lovely little drawing of the axis in free space. X, Y, and Z. Okay, line is the y-axis. So what would its equation look like? X, Y, Z is equal to. Okay, so I need a point on that axis. Okay, so basically all the points on the y-axis are 0 and then something and then y. Okay, sorry, 0, y, and then 0. Okay, doesn't matter which number I use. To make it super simple, let's just use the origin. Okay, 0, 0, 0. Okay, what does a direction vector look like on y? Okay, well, it's just in that direction. So say I go to the next point, my next one would be 1, 0, 1. So that's a possible direction vector. Just it could only move along the y-axis. So I can only have that y coordinate filled in. Okay, so that's what my y-axis equation could look like. Okay, give a possible equation for the second line in each of the four cases. Well, what were the four cases? One case is that they intersect. Okay, so if they intersect, what would that mean? Well, it means they share a point. Okay, so my new line we just have to have a point that is on the y-axis. So I can use my origin again. Okay, and now if I want them to be intersecting, but not infinitely, right, at one point, I just need to have a different direction. So maybe I do 1, 1, 1. It's definitely a different direction. And I know it crosses the y-axis because it passes through the origin. Okay, case 2, they are parallel. And the same. Oh, right, my two lines in space, I would have my y-axis, and I would have something parallel to the y-axis. So that means its direction vector is going to be the same this time. X, Y, Z equals, so I had 1, 0, 1, 0. Okay, now to make sure it isn't the same as the y-axis, that means the point that it passes through can't be on the y-axis. It can be anywhere else in space, it's not on the y-axis. So maybe I'll do 1, 0, 1. Okay, and that's not on the y-axis. Okay, case 3. Parallel and coincidence. Okay, so that really means that my new equation is actually still the y-axis. It's the same line twice. So x, y, z equals. So to make it look a little bit different, let's play with it a bit. Instead of using the direction vector 0, 1, 0, let's call it 0, 2, 0. It still goes along the y-axis. And for the point, I'll pick a different point that's on the y-axis. Say, I don't know, 0, negative 71, and 0. Right, this is a y-intercept, right? No x, no z. So that's on the y-axis, and this runs along the y-axis. Okay, fourth case, skew lines. Okay, so they do not go in the same direction, but they don't cross each other either. One of them kind of passes over the other line. going to have to be a little bit careful here. So I have to make a point that's definitely not on the y-axis, and I need a direction vector that's not going to put me on the y-axis. So let's think a little bit here. I'll start with my direction vector. Let's make something up for this. Let's say it is, again, I'll go with that 1, 0, 1 thing here. Okay, when I'm picking my point, I'm going to have to make sure that there's no way that this direction vector will put me back onto the y-axis. Okay. So let's say if I made my point, there we go, 1, 2, 3. Okay, I know for sure that this doesn't have a y-intercept. Okay, and the reason that is because to make a y-intercept, I would have to add a scalar multiple of this vector to this one and make that 2 disappear. Okay, but I can't do that because I have a 0 in this position. Doesn't matter what I multiply my direction vector by, I'll never be able to add it to my point and have that equal 0. Can't happen. So, oh, wait, sorry, that's not quite correct. Right idea. It's not that I have to worry about. I'm sorry. Okay. It's these I have to worry about. I can't make those both 0 at the same time. Okay, back up. Okay. But we can see that's going to be the case here. Okay, if I subtract my direction vector right now, this 1 would become a 0, but the 3 would be a 2. So it's not going to change. Okay, another way you could convince yourself would be just run through the process of solving, try to solve for a y-intercept and see if it works or not. Okay, sorry about the little confusion there. I got myself off track, but that's the goal. I can't have a y-intercept, so I got to make sure that I can't make those both 0 at the same time. All right, so that was the homework take-up, and keep sending in your questions, and we'll answer those tomorrow.